So
Bravo claim.
we will stop that for discussing about the measurement results. We will go back to that in 10 minutes or something like that. But I want to first start the. I want to first start the LabVIEW program for the determination of the efficiency of the air collectors. Okay, it's still it's still here, the same program, Concordia.
Waco is the switch.
We set that to air collector, and we want to suck the air from the room, right? Because we have open loop.
Sorry.
Then we can start the program. What we did not think about is to switch off the data acquisition unit. That's what I already told you. It will tell you that it's locked by external process. That's the IP address of the external process. So we have to switch off the data acquisition unit in the central control system. Okay?
Yeah. Is it?
So, nobody is now locking the system. So, what we have at the moment, set temperature, it will not care about the set temperature, and it's not necessary to care for the open loop system. Is we don't care about all these things because we are not able to vary the inlet temperature. Actually, it will not check that. So what we see now is here it's the power output water, and we see the mass flow of the air circuit this time, and the specific heating enthalpy at the outlet of the collector, and the specific heating enthalpy at the inlet of the collector, and by the mass flow and the specific heating enthalpies in the power output is calculated.
How do you know which one's inlet and outlet?
The higher one is always the outlet, the lower one is the inlet.
The difference in the specific enthalpy.
Excuse me?
Surprising the difference in the specific enthalpy.
And then we see the temperatures. It's also gathering the water temperatures. So actually you don't have to consider them. The only one which are interesting are the ambient and the ventilation.
These are the artificial sky to ventilation.
This is in the artificial ventilation units in the cross flow fans.
Not the sky.
Not the sky. We have cooling water, which is also not so important because it will heat up because the pump is not running. We have in air. This is the second sensor. This is not connected, so it will show a value which is garbage. This is out air, which is 34.3. We will see the mass flow air, which is 33.14. And heat exchanger out air makes no sense over here, but this is the one which is at the outlet of the water air heat exchanger, what you would have for if you have a closed loop circuit.
Maybe check if the Kundensystem
Maybe I can put a picture in order to.
So this T ambient is it used?
That's up to you in the end.
It's the one that is behind the collector, yeah.
That's the one which is behind the collector. Jude, do you have the plans over here as well on this computer? Like all the plans from the...
Is it quite different from the inlet temperature?
It's a little bit because it's in the shadow
All that, otherwise
and
I give you
behind,
that this.
so, which gives better results actually.
Well, the inlet temperature is the one we want.
All the manuals.
Yeah, we want the inlet.
We want the inlet.
Yeah, otherwise I will use the...
And that T ambient is behind the collector on the platform. So not collector, but it's in the middle of the platform. You know what I mean? So where the specimen is.
No, not
Where
water.
T in air.
That's ventilations. That one is warmer.
Where's T in air? Inlet air.
We don't have inlet air.
There is no-
because that's not connected. What we have is ambient. What is ambient, and we have the two in the ventilation unit.
Then how does it calculate the inlet air amplitude if it doesn't have the?
Considers the ambient temperature.
Oh, okay.
So
Right. There is an option using room air as inlet, right?
Yes.
So that you know.
If you press suck air from room, then the program considers the ambient air as the inlet air.
So what is it doing now for the inlet air? Is it taking the average of these?
no, ambient.
Oh, okay. And
That's what it's
setting from
yeah.
here.
Okay, I give this to everybody.
And can we see the temperatures that are near the ventilation fan?
These are
Log out, not share.
these two.
The ones that are below this wind that
They are in the wind generators. So these are these two ventilation left and right.
this is not for the sky.
No, that's ventilation. That's not for
Sorry.
sky. The ventilation is the cross flow ventilation, which blows the wind on the
Simulating wind.
the simulating wind. So
Okay, so these are these values.
these are the two. So this is why there's a difference. This is why I say you can do it either the one way or the other way. So, but this program here, if you press this, suck air from room, it considers this as the inlet temperature.
Where is that sensor?
Have we got that sense? Suck air from room or not? We are.
We are because we suck air from room means
That's what we're doing.
we suck the air from the room.
Got it.
That's an open loop.
I think we're doing that too, aren't we? Yes.
Yes.
Sorry.
In all the air.
Not much
The
left.
ambient temperature sensor is under the platform.
Yes.
Shaded.
Yeah, and it's a double shaded. So what it's made of? It's a reflective aluminum tube, and there's a second tube, and we have a fan, and this fan is sucking the air through both, so it's double shielded from the irradiation, and the one is inside in order not to heat up the sensor. The first one is just reflecting, but that's heating up a bit. So, and then we suck with the ventilation unit also from the outer tube, and then we try to get rid of all the infrared radiation to the sensor as well.
Yeah, but there's another set. There's another set?
Okay, that's the room, that's the relative humidity, that's the air temperature of a different room. So we have a big under pressure.
You should have another one.
This is very small. The last one. DP
Deep
collector.
in, out, air.
I think I finished.
DP collector in and out air.
Pressure difference.
Okay, that's good. And I finished to figure out how to work.
That's what we measure.
That's the
Yeah.
pressure drop across the orifice.
I finished
Huh?
one.
That's the pressure drop across the orifice that's measured.
Across the collector.
Across the collector.
Okay.
We're not pulling much, are we?
Because the collector is all, I think, because we have a lot of openings from the collector. I guess this is why it's very, very small. Yeah. So, controller, what you see now is that it's controlling now the air mass flow. I don't know what we want to set.
Value, yeah.
100
this is
kilogram per hour.
Yeah, more or less.
So maybe we talk. So that's now gathering data, right? So maybe we talk a bit about. Normally, then you vary the mass flow, right? You do 2 or 3 variations if you suck the air from the room, right?
Yeah, more than that. But
Yeah.
just-
So this is what we also we can do to set. What we can do is also to set a one or 2 different mass flows. But maybe we also talk a bit about what happens if we have a closed loop circuit. So just for you to know what is happening if we have a closed loop circuit, what you would do then is
Turn that
don't
off.
press that button because we have a closed loop circuit. We don't suck the air from the room. Somehow it is also from the room, but it's a closed loop circuit, right? What you could also do then, you can set a temperature, because then you can set the temperature at the inlet of the water-air heat exchanger. So I can maybe I open the picture then. Product plans.
No, it's okay. No, I don't need it.
Sure?
Yeah.
Just want you take good photos, videos.
It's good. It's good. I'll get a prize.
Okay.
No, thanks.
It's okay? Alright.
Maybe also then you can set this temperature at the inlet of the water air heat exchanger
Because I was thinking all year.
It's okay.
by setting the temperature over here, as long as you
Can
are
you
for
please?
or also here. You can set
You're so young.
this temperature. Actually, this temperature here you can set. It will not be exactly the same as on the outlet of the collector, but what we are doing is, if you have a small mass flow in the water circuit, you will have a big delta T from the inlet over the heat exchanger. So what we do for that is, if you go to controller, you can see that the mass flow is 500. That's just to have a higher mass flow than regularly for collector testing. So talking about, for example, also if you want to test the collector, which we tested yesterday, for water and for air, both at the same time, open looped collector circuit, you could vary the mass flow of the water over here, for example. Or you could also go, don't press suck air from room, having air collector tested, and then use this one. The problem is this thing here, the mass flow, this will be the variation of the air mass flow then. Do you understand?
And you have to go on the other tab for the
You
water
could
flow.
go to the other tab and vary the mass flow over here for the water then. Do you understand that?
It's a bit complicated.
It's a bit complicated. You could change the program as well, that you have the opportunity to test water and air at the same time.
And is the reason just to be more efficient testing by doing this?
No, the guys from yesterday, they asked you if you can test the the collector they delivered, air and water at the same time, right?
That's how it's
Do?
designed.
Yeah,
What does it mean, testing air and water at the same time?
Their
Be-
system,
because it has a
system
water
is a
loop.
water collector with
No.
air like yours.
So this
Oh.
air collector, water collector combination.
Oh, using
So-
air and water as the working fluid at the
Yes,
same time.
at
in
the same time.
It
collector.
has heated air that
Oh.
heats the water.
So there is a
Was the air heating the water?
Yeah.
What do you heat the
So
air?
this
Does
one
that sound
is for
right?
the water
if you
Heating
flow.
water.
if you
and
are
the water.
if only if you
Because
you are
in
at
the
air
house they
collector
use
testing,
the
Are they trying to
From indoor
Exhaust?
outdoor exhaust.
This one is for the water
It's
flow.
air to air for the exhaust.
If you are
Well, it's their idea. They said it works better like that.
testing,
So
this one is for the water collector
You're not
test.
going to get much delta.
I
T
haven't
in the
considered
water.
when I made
It's
the
interesting
program. I've
concept.
never considered having something like a air water combination collector. No.
Get heat exchanged from air to water. That just sounds crazy.
Oh,
So you
Why
only
wouldn't they
to
just do air to air to capture the waste heat of the air?
I
because
don't
they,
know.
Because
it's
they need new
For
air
their
coming into the house
air
at some
water
point.
collector.
That would be the most
means
efficient.
there are
well,
two
I guess the priority was
channels.
water
One
because
in
they
the
use
air, one
radiant
in the water.
systems
That's correct.
in Finland,
Yes.
in Europe.
Still.
so in the other one
It's for like hydronic systems, not for ventilation. I mean, it's their system, so
controller.
So let them have it.
Yeah.
This one?
They-
That's a bit complicated.
it's a product.
You have
We can test it if we can
Yeah,
somehow.
the-
So.
yeah, it'd be interesting. I'm sure we'll learn more.
Yeah,
Right.
actually, it's interesting. I never
Yeah.
thought about it too. You know,
Right?
so
It always it just
Yeah.
controls this.
So you can use the water for storage is a great idea. That's a good idea.
it's for space heating, not storage.
Yeah. Oh, right, for radiant heating to feed the radiator.
Heat the slab.
Okay, but
That's a
that's
nice
how we
technique.
work
Oh,
the
that's-
sensor. Well,
yeah.
It's in
where
Europe,
we
it's
put
like
it in
that.
the programs, but we can see from
Yeah,
the
yeah.
from the sensor which
That's
thing
right.
is measuring.
Yeah, that's
Yes.
nice.
But it's
But for capturing waste heat from air,
Just increase a little bit the efficiency, maybe. I don't know. They
I
never
just
said.
wanted
There,
to.
you know?
These guys asked me yesterday, and they asked you if it is possible, in principle,
Yeah.
to test both. I say yes, and I try to give you the way. What I would not do. What I would not
we'll
do.
call you.
Yes, but maybe 1 second for
Well,
understanding.
there is a way.
You have to go for air collector, right?
Uh-huh.
Then you use this thing. I would not use the schedule. Believe me, I would not use the schedule.
I almost never use it because it seems to have some problems. I didn't even have time to try it out.
Okay.
Yeah.
So what I would do is go on air collector testing, right?
Mhm.
Then don't use suck air from room, but press temperature control of thermostat via lab view. You have connected the water loop to the collector.
The air collector.
No, you have to the collector. I don't say it air or water collector. You connect the water loop to the water tubes of the collector, and you connect the air loop to the air loop of the collector. Okay?
Yes.
So then you press here on air. You don't press suck air from room.
Is the air closed loop and the water open loop?
No,
Right
the
now
other
it's-
way around. The other way around. The
Okay.
water is closed loop and the air is then open loop.
Okay.
Okay?
That's what's confusing because normally open would mean for the air to suck it from the.
Yeah,
But in this case, okay.
maybe you can also. Wait a second.
Would it be just easier to test the
Right now
water
it's selected.
system with this program? And I know that Jivo and Ting they use their own LabVIEW software for air, so they can just test it, you know.
But they don't. Do you measure the mass flow as well with your own program?
No,
They use
I
this
just
So
get the
you
data
will need
from-
the mass flow through,
Yeah.
through the collector then.
Can you improve it? Is it hard
To what?
to measure mass flow with your stuff? With
I
the
think that one is good enough. So the mass flow meter is really, if you put in, it will have a lot of pressure drops, and to get accurate mass flow meter is not easy. You need really a long distance to get the flow stabilized before and after. So we don't have that space. We could, but we don't need.
So
Or the another way is just take from the transmitter of the other mass flow, measure the voltage. So measure the Simpson twice to make it easier.
so
It's
but after
possible,
that one.
but we didn't do it because she always needs this
And you can tell
data.
us.
Okay, I understand.
Okay.
So the
So let's continue the how to do water and air together. I'm really
Yes.
interested.
Okay. You press on air. You press temperature control of thermostat via lab view because you want to vary the temperature of the air circuit. Maybe I draw a picture.
Yeah.
Mm,
Take it from the.
It's okay.
You wanna
You
set
can
the
just draw it
inlet
here.
air temperature.
Maybe we can take this one.
Here. Oh, okay, that's better.
Okay, we should use this and
With
for
their
the
system, you
for the
specify the
copy.
air
Okay.
inlet
And
Send
he's
it
gonna
back.
also send us instructions.
Okay. Okay. And then you have okay. You suck the air from the room, right? Here you have your air mass flow meter. You have your temperature sensor here. I would install or just connect the other temperature sensor as well. Okay, and then you have just the normal air collector setup, right? Open loop, but don't use the suck air from room button because you will not be able to vary the temperature of the thermostat then. Maybe you are.
The temperature of what?
Thermostat.
The inlet temperature.
So
Of this room.
you want to
Because it's the room, you don't
You
control
want
the
to-
room temperature.
normally if you test a water collector, you want to vary the inlet temperature of the collector, right? You want to have something like this, right? You want to vary the temperature on different steps, right?
Yes.
So then you press temperature control of thermostat via left view. This is what you want to do. You want to control the thermostat via left view.
So the thermostat is of this.
This temperature control unit,
The box.
the box, the silver box.
Okay.
Huber.
Huber is the manufacturer. Okay.
Something passing out through
If you go then to measurement schedule, if you are on air collector testing, this temperature here, temperature ment, is controlling the temperature of the inlet of the water side.
Oh.
Okay? This temperature is controlling the water temperature. Okay? This mass flow here is controlling the air flow. Okay? This is why it's a bit complicated. This thing is
Water, and that one is air.
this one is air. But you also have the as I said, we have never thought
Yeah,
about
yeah,
testing water and air at the same
No
time.
worries. No worries.
So, and then you have to go to controller. Here's controller. And over here in this, only active for air collector measurements is written here.
Water mass flow.
Here, during air collector measurement, you can set a mass flow for the water to vary the water collector side.
So that was set up for the heat exchanger.
That was only set up for the heat exchanger originally, but you are somehow testing a heat exchanger, right? So this is actually what you would do to treat the collector as the heat exchanger in the closed loop air collector test. What I would not do, you should vary that on your own, wait for an hour, go to the next temperature level. What will not work is using this schedule. This will not work at all. This will be too complicated. I have not really thought about that yet, but this might be too complicated to use that. So set the water inlet temperature here, use the air, put the air temperature here, and go to the controller in order to set the mass flow of the water.
Can you set the air here or
No, the air is
it
not.
has to be set there?
The air has to be set here.
So that air temperature is almost same as the water temperature? Close.
Excuse me?
whatever you
So
want
the
it to
water
be.
temperature will be fixed if you do this way.
No, afterwards go to 40. You run the test for an hour and then you go to 40
The
degrees.
inlet of water temperature.
The inlet of the water. If you go for air collector testing here and go for setting this temperature,
Mm-hmm.
then you will set the inlet temperature of the water on the water side.
So this is for a closed loop test.
No, it's for the guys
Testing
yesterday.
together.
The
Yeah.
gu- the
Oh, you're
guys
talking about
yesterday-
yesterday's experiment. Okay.
They
Water and air.
wanted to. They asked you, Ju, I think. They
Yes.
asked him to test the water collector, the water side of their collector, and the open loop air collector side at the same time. So, in principle, this is possible with the program,
got
but
it.
we have never thought about that when we were
Okay,
designing
got
that.
it,
So
got
this
it.
is why it's a bit complicated.
Also, to be testing is a combined
Yes.
water collector and open loop air collector.
Yes,
Yeah.
this is what I'm explaining at the moment.
Yeah.
So, in principle, possible. You would, yeah.
Now let me ask you something. When you are setting the mass flow rate there,
Yeah,
it takes into account the change in temperature, density, and everything.
sure. I can. I have not seen that program for quite a long time. But
It's so huge, you can spread on the whole lab floor.
They
This
did
is
it
the
so
LabVIEW
neatly
with
with
Yes.
all the
Yeah.
no crossing lines.
I have to think about calculating.
They have like the
temperature.
So who
the way
knows
they show
LabVIEW
you
now?
the program.
Who has learned LabVIEw now? Well,
We are-
apart
we are-
from
Everybody
you.
now.
Everybody theoretically.
Everybody now
did the
know a little
training.
bit. Everybody did a training.
Familiar.
Yeah. Now
How are
for
you doing with
them,
the LabVIEw?
Beautiful.
Yeah, and this is a guru level.
I think there is a temperature sensor
Yeah, I've used it
before
for
the orifice.
2 hours.
Set up.
Yeah,
We're all
I
experts.
know, but I wanted to show what it's
There's a
taking
friend
to.
we
Fantastic.
really need.
the exact calculation. Yeah.
Yeah.
Copy theirs and
Butcher
butcher it up.
air here.
Temperature
Butcher air.
So
Yeah.
that's
That
also
makes
Somewhere it is.
Can you just zoom out somehow?
No, that's the silly thing about LabVIEW.
Yeah, the mouse doesn't work, and you cannot drag video. That's really. No,
You cannot
that
drag.
you
Huh?
the interface is lagging behind for
It's so
a number
long
of years.
ago
They've
that I.
always been like that.
They just want to zoom in.
to get everything high resolution.
Things are familiar.
And the stereo is so expensive.
It's
So.
not
Of course.
they don't care.
Increase.
Now the worst
Oh, that's
thing is
water.
they keep
That's
updating
water.
every year, and you have to buy on.
Yeah, you have to buy it and it's not backwards
You have to
compatible.
No,
I mean, if you save it in the
Yes,
newest
yes.
one, you can't open in the old
We're
one.
going to ask Dr. Fazio's students if some of
Can
them
you?
want to attend that. Yeah. Do you want to attend this? There is an IP course in Toronto. What?
What is it about?
Intellectual property and this kind of thing.
oh, that's a great.
Do you have an email on that?
Yeah.
Ah, here
Why
it is.
Okay. Yeah. Anyone else?
That's two professors already.
So give me. Can you?
No,
give
I
me
don't
an
think
email
any.
address? Why?
But we Joseph sent the email to everyone, I think.
Him,
Yeah, that's the best.
Huh?
Stratos.
Stratos?
I haven't checked yet.
If it's Stratos and Collins, so all professors are considered.
I think.
So now we're going.
I think Joseph sent it to everyone. To all the
What?
professors.
Yes, that's what it's all
Okay,
considering.
so-
That's what I
Mass
thought.
flow,
He already sent it. He already sent
differential
it. Yeah.
pressure.
So that's
Okay,
Um,
so we're fine.
yeah.
Okay.
but so you can have two, but still for three
Well-
professors.
Okay.
It takes into account, and it's always
someone
checking
No, also the
if
students have to be
if
interested in
the
this.
volume flow is measured according to the ISO
So they should go to the
518
professor.
so it's
Let's
also
focus this for the
checking.
time
Yes.
being, we'll deal with it on Monday.
It's also checking if the dew point of the because the values would not be valid if we are below the dew point. So it's always also checking if we have the dew point, and then it's calculating the specific enthalpy at the entrance and the outlet. So it's
So it takes into account the humidity too. The
yeah,
humidity
sure,
content.
sure,
Yeah, okay.
sure. But it has to.
That's a
Water
full
content,
calculation.
yeah.
Yeah. So Andreas, maybe for you, I already talked or got the information from Germany about the orifice.
Yes, yes.
To change that.